Hi guys and welcome back to my channel. This is episode 8 of the Carbon Cycle and Energy Security Revision Unit over here on my channel. Today we're going to be looking at the threats to the carbon and water cycles. So please do subscribe, share this with someone who you think might find it useful. I'll try and remember to link the rest of the playlist up here. There's a load of other playlists of things like different revision series already up on my channel, so go ahead, find them, watch them to your heart's content, and I hope they're useful for you. So without further ado, let's just get straight on into this video. Growing demands. Climate change is happening. The first 2 decades of the 21st century have brought extreme droughts in Brazil, Australia and the USA, and torrential rains and flooding in Europe, Japan and South Africa. At the same time, average global temperatures are the highest on record. In addition, growing global demands for fuel, food and other resources have led to land use changes which are threatening both carbon and water cycles. Deforestation in Madagascar. Since the 1950s, Madagascar's tropical rainforests have been cleared at a rapid rate. Small-scale clearance by farmers has long been common in the country, but a growing international demand for tropical hardwood, an expanding population and debt repayment meant that the Madagascan government began to encourage farmers to clear more land in order to grow cash crops, to earn foreign currency to help repay the country's debts. Before 1950, Madagascar had 11.6 million hectares of tropical forest, but by 1985 it had been reduced to 3.8 million hectares, a loss of 2/3. There are high levels of predicted deforestation in Madagascar's Andapa forest by 2030. As the rainforest disappears, so CO2 emissions increase. Deforestation has a major impact on the size of terrestrial carbon stores. Removing the forest has a colossal impact on both fluxes and stores. Deforestation also affects rivers, landscapes and soil health. The waters of the River Sofia and Betskeboga have turned red as a result of soil erosion caused by deforestation in Madagascar's Central Highlands. Soil erosion now exceeds 400 tonnes per hectare per year in some areas. Extensive logging of inland rainforests and coastal mangroves mean that after heavy rainfall, soil is washed from the hillsides into streams and rivers, eventually clogging the coastal waterways with sediment. Converting grasslands to farming. Between 2007 and 2015, a biofuel rush swept across the American Midwest, often referred to as the prairies. Farmers were encouraged to grow corn, soya and canola, a type of rapeseed, and sugarcane as part of the US Environmental Protection Agency's Renewable Fuel Standard policy. This policy aimed to increase the amount of ethanol being used in petrol, boost the economies of rural US states, reduce US dependence on overseas oil imports and reduce CO2 emissions from transport. The growth in biofuel crop reflected a growing global demand. By 2013, the price of corn had trebled, and a number of US states, such as North Dakota, were cashing in. Grasslands traditionally used for cattle ranching were ploughed up, and in some states, the area of corn being cultivated doubled. Over 5.5 million hectares of natural grassland disappeared across the American Midwest, which matches the rate of deforestation across Brazil, Malaysia, and Indonesia. The impacts of converting grasslands. When natural ecosystems like grasslands are destroyed, there can be serious consequences for carbon and water cycles as well as soil health. America's Midwest is prone to dry summers and is at risk from wind-blown soil erosion, which would also have a detrimental effect on the soil carbon store. The benefits of natural grasslands. They trap moisture and floodwater, absorb toxins from soils, maintain healthy soils, provide cover for dry soils, maintain natural habitats, act as a carbon sink, and act as a terrestrial carbon store. The disadvantages of converting grasslands to grow biofuel crops. The initial removal of grasslands releases CO2 from the soil into the atmosphere. Annual ploughing enables soil bacteria to release CO2. Biofuel crops need carbon-based nitrogen fertiliser and chemical pesticides, so they produce a net increase of CO2 emissions. Biofuel crops are heavy are heavy consumers of waters, so they need irrigation, which has significant impact on aquifers. Cultivated soils are liable to erosion by runoff and wind. Natural habitats are reduced and the lung effect is reduced. Afforestation. Trees provide a vital carbon store, sequestering carbon during photosynthesis. Therefore, it makes sense to replant trees when deforestation has occurred, or better still, to establish forests on land not previously forested. This is known as afforestation. Afforestation effectively counters all the negative impacts of deforestation that we've just talked about. The EU's Afforestation Grant Scheme encourages the planting of forests for their value as a terrestrial carbon store and for the ecosystem services that they provide. Ocean acidification. The world's oceans are a major carbon sink. They have absorbed about 30% of the CO2 produced as a result of human activities since 1800, and about 50% of that produced by burning fossil fuels. This picture shows that as CO2 in the ocean increases, the ocean's pH decreases. It becomes more acidic. This is known as ocean acidification. As the ocean becomes more acidic, corals cannot absorb the alkaline calcium carbonate that they need to maintain their skeletons, and reefs begin to dissolve. Ocean acidification has lowered the pH of the ocean by about 0.1. This means that it is now 30% more acidic than it was in 1750, in the early days of the Industrial Revolution. Corals matter. Corals, which are marine invertebrates, get their brilliant colour from algae that live in their tissues. The most important role of the algae is to provide food to the coral through the hydrocarbates produced during photosynthesis. Coral has a narrow temperature range in which it can live, never below 18 degrees centigrade and ideally in the range of 23 to 29 degrees. If water becomes too warm, the algae are ejected and the coral turns white, known as coral bleaching. The biggest cause of coral bleaching is climate change, which raises ocean temperatures. If CO2 emissions continue at their current rate, the pH of the ocean will be lowered to 7.8 by 2100, which would dissolve coral skeletons and cause reefs to disintegrate. Increased acidification risks crossing the critical threshold for the health of coral reefs and other marine ecosystems. If coral reefs are destroyed, they will lose the vital ecosystem that they provide. They shelter 25% of marine species, protect shorelines, support fishing industries, and provide an income from tourism. Increasing drought. The natural greenhouse effect keeps the Earth warm enough to sustain life, but increased carbon emissions are enhancing the greenhouse effect so much that the global climate is changing. Climate change could have several impacts, including an increase in the frequency and intensity of storms and hurricanes, rising sea levels, more frequent floods, droughts, and heat waves. Any change in ocean currents and atmospheric circulation could also affect patterns of precipitation, evapotranspiration, and temperature, as climate belts move in response to climate change. As the planet warms, not only have the Earth's climate zones begun to shift, but according to climate scientists at the University of Colorado, they are also doing so at an accelerated rate. The scientists use climate model simulations to investigate shifts in climate zones. They found that for an initial 2 degrees centigrade warming, about 5% of the Earth's land area effectively shifts into a new climate zone. The pace of change then quickens for the next 2 degrees of warming, with an additional 10% of land area shifting into a new climate zone. Certain regions, such as North America, Europe, and other mid- and high-latitude regions, will undergo more changes than tropical and subtropical regions. In addition, the colder zones of the planet are increasing in extent, and dry areas are increasing. It's likely that today's arid and semi-arid areas will expand into continental areas of Asia, as well as parts of northern and sub-Saharan Africa. Drought in the Amazon. The Amazon basin suffered severe drought in 2005 and 2010, and the drought of 2014 to 15 was the worst hit for Brazil in 80 years. The Amazon basin plays a key role in the Earth's carbon cycle, holding 17% of the terrestrial vegetation store. A study of the 2010 Amazon drought showed that trees died and growth rates declined. The drought effectively shut down the Amazon's function as a carbon sink. Forest fires broke out, burning trees and litter and releasing CO2. There are increasing concerns that as climate change increases temperatures and alters rainfall patterns across South America, the Amazon rainforest will change from a carbon sink to a carbon source. This could accelerate global warming. And that is the end of episode 8. I hope you have learned something. Please do subscribe down below if you think these are useful. Go ahead, find the rest of the playlist on my channel, and I will see you same time, same place next week, Monday, 4:30 p.m. Bye guys.